Hi all, welcome back to Node.js tutorial course. I hope you all have watched my previous sessions which explains different concepts of Node.js and live coding examples of it. If not, I have given the links in the description box. Please do watch. So in this session, we will explore one of the most powerful features in Node.js, that is buffers. So if you have ever worked with binary data like files, images, or network streams, you have likely come across buffers. But what exactly are they, right? So buffers allow Node.js to handle the raw binary data directly, making them essential for efficient processing in file systems and also in the streaming data and network communication. So unlike basically the JavaScript strings, buffers give you low level control over binary data, which helps you to manage things like encoding, decoding, and even data manipulation. So in this video, we are going to break down what buffers are, how they work, why they are so critical in Node.js application. If you want to level up your skill and make your Node.js apps faster and more efficient, stay tuned. And don't forget to like, subscribe, and hit the bell for more tutorials. Okay, so what exactly is a buffer in Node.js, right? So a buffer is essentially a temporary storage area specifically designed for handling the binary data. Okay, so basically, unlike like typical JavaScript strings, which are made for handling text, buffers allows us to work with the raw data directly. Okay, that is the use of buffers. So buffers are crucial when you are dealing with things like file system or network connections or any kind of data streaming. So they enable us to manipulate this binary data efficiently without needing to convert it to a text format first. So this makes buffer highly efficient for tasks like reading and writing files, transferring data over the network, or processing streams of incoming data. So with buffers, we get low level control over the data, which is why they are key part of handling data heavy or real time applications in Node.js. So why to use buffers, right? First, as I said, it's binary data handling. Like buffers allow you to work directly with the binary data instead of text, whereas in the JavaScript strings, we usually handle with the strings, right? Next is streams, like essential for working with data streams like file, input, output, network connection, where the data is processed in chunks. Efficient memory use, like buffers provide like efficient memory management for large amount of data. Okay, performance wise, it's faster and more efficient when dealing with raw binary data like images, videos, or encrypted files. Okay, so low level control, as I said, buffers offer granular control over data, which is crucial for tasks like compression, encryption, or protocol handling. Last but not the least, encoding support easily convert between the formats like UTF-8, Hex, or base 64. So what are the common use cases of Node.js buffers, right? Well, first, file handling, reading and writing binary files like images, videos, or audios, streams, basically managing chunks of data in stream for network connections or file transfers, data encoding and decoding, handling data in various formats like base64, hex, or UTF-8, image video processing like manipulating the raw uh, images or video data. So that is another use case of buffers. Cryptography, as I said, encrypting or decrypting data using raw binary formats, compressions, working with compressed data formats like gzip, zlib, right? Networking, like managing TCP, UDP data packets in binary form. So these are the common use cases of buffers. So now let's see how we can use buffers, how we can write the coding or with live examples on buffers. Okay, so now let's see how to create a buffer. Okay, let me just create a folder for buffer demo and I'll just create a file buffer.js. Okay, so now let's see how we can create a buffer. So first let's see create an empty buffer of size 10 bytes. Okay, so what we will do, const buffer equal to buffer dot. So buffer is an like inbuilt available within the Node.js, so you don't have to import it explicitly. Okay, once we have the empty buffer created, the next comes the creating a buffer from the array of bytes. Okay, so what we will do is uh, this is how we create an empty buffer, and now we will create a from array of bytes. So what we will do, buffer from array equal to, so what we will do, buffer dot from. So you can create a array like this. So we can create 65, then 66 or 64. This is how you create from the uh, from array. Okay, from array. Next, if you want to create from a string, right? So what you can do is const buffer from string equal to buffer from, you can create like hello world, and we have to do a encoding, right? Which format we need, right? So UTF-8. Okay, this is how we should be. So so basically this allocation size allocates a buffer of specified size, and then we will use from array and from string is the option how you can create a byte. So if you want to see how it is created, so let me just print console.log. So I'll just print this, so like this. Okay, then I'll print this from string to see how it's responding. Okay, so let me go to buffer demo, then buffer.js. So you can see it has created the buffer for strings and then array. Okay, this is how you can create a simple buffers and uh, create a buffer from the array of the string. So now let's see how do you read and write data to buffers. Okay, so what I'll do is we do have this allocation 5. So what I'll do, I'll just change this to 5 for now. 5 size I'm going to give. Then what I'll do, buffer dot write. So what I'll do is hello. Okay, so I have we will use dot write function to write to a buffer. So if I just do console.log of buffer, it gives you the buffer details. Okay, what has been written in terms of hello. Okay, it's raw buffer, what we are going to say. Okay, so let's run this. Maybe we will also read the data from buffer, and then we'll write it once, sorry, run it once. Okay, so what we will do is reading data from buffer. So first byte equal to buffer of 0. Okay, then this should give you buffer of 0 is nothing but h right here, so it will give you h. Okay, let's try to print it. Okay, console dot log, console dot log of. So what we will do is because it has to be it's in the byte format, right? So we have to convert that into a character code. That is how you get the representable or readable format. Okay, so let's try to run this, and you can see that it has created this buffer for hello, and it has read the uh, first character in that hello. Okay, next we can see converting buffer to a string, right? So what we will do here is const buffer string equal to buffered dot to string of utf 8. Okay, so we have converted this buffer to a string, and then let's print it console log. Okay, dot log of then buffer string. Okay, so it should print you hello. And see, it has printed the this is how you convert the buffer back to a string using the specific encoding. So now let's see how do we modify the buffer, right? So what I'll do here, I'll take another buffer called buffer modify equal to buffer from, I'll just create like tech stack. Okay, so this is a buffer I have created, and I want to modify the first byte to something else. Okay, maybe from what I'll do is buffer, so buffer of 0 equal to 7. What I'll do here, I'll just put this as a Node.js only. Okay, node.js, and buffer 0 equal to 78. So modifying the first byte to n. Okay, then let's try to print this of buffer uh, buffer dot to string. It's a readable format, correct? So that's why we will use the to string. Okay, so if you try to print this, you should be able to see I have changed yeah, buffer from Node.js, and I have changed. Yeah, I think we have to use this. Sorry, it has changed that. Okay, so if I just change this to uh, text stack. Okay, so what happens is it will so I'll just give this buffer mod string, so it should have changed the value from nt to n. Okay, this is how you modify the buffers. And also we will see buffer size and length. Okay, buffers are fixed in size and cannot be resized once created, right? So as you see, this is how you allocate the size, and if you want to display the length of this buffer, right? So what we can do here is you console.log, we can put buffer dot length. Okay, so this should give you the length of the buffer. Okay, if you attempt to try write more data than the buffer size, it will be truncated. Like uh, for example, I have allocated it to 5, correct? So now what I try to write beyond 5, like buffer dot write of like too long. Okay, because it's more than 5, correct? So it will truncate. So let me try to print this console.log. So too long. Okay, then I'll print buffer. So you can see it will be truncated. Let's run this. Okay, say buffer length is 5, and yeah, here. And if you want to do like, we need to see the to string, right, the readable format, so we can do this way. You can see it would have been truncated now. See, it has taken only the 5. So this is how you manage the buffer size and length. Okay, okay, now let's see how do we concatenate a like, we will see how are we going to concatenate the strings. Okay, so what we will do is let's create one buffer, const buffer 1 equal to buffer from, so I'll just create hello. Okay, so I have one buffer here, and I'm just going to copy paste this with second buffer for world. Okay, world. So now I want to concatenate these two string. Concatenate buffer. Okay, so what I'll do here is I will be just using buffer dot concat. Okay, then I'll give buffer1 buffer2. So this is how we concatenate the string. So it should be within the array. Okay, that is how we do it. So this is how we concatenate the buffers. So let's try to print this and see how is it working. Okay, two, as you know, if you want in a proper readable format, then always use this to string. Okay, so let's try to run this and see how is it working. You can see it has been concatenated. So this is how you concatenate the buffers. Now let's see how to copy the buffers. Okay, what I'll do is I'll just create this buffer3. Okay, and then what I'll do is I'll allocate another create another buffer with some size, and then we'll try to copy that. Okay, so let's try to copy the buffer. So what we will do is we will do buffer3 dot copy of buffer4. This is how we copy the buffer. And now if you want to print this copied buffer, right, copied buffer, so what we will do, buffer4, then we will be able to see the values. Okay, let's try. I think so. Okay, yeah, it has been copied. This is how you copy the buffer. Now slicing, right, if you want to slice the buffer, uh, that also can be done, right? So again, I'm going to copy this we'll try to slice the buffer. So I'll just name this as fifth buffer and sliced buffer. Let's sliced buffer equal to, so buffer 5 dot slice of what I'll do is 0.1. So I'm going to slice the first one. Okay, so what I'll just slice the first one alone, so we'll see how the response is coming. You can see it has sliced the first letter and it has given the value as h. Okay, so next we'll see comparing the buffer. So what I'll do is I'll just copy this to we'll just put this as ABC, ABC. This one I'll give it as 6, then 7, then I'll create another one with the different. Okay, I'll just name it as XYZ, so it will be 8. Okay, now let's see how do you compare. Okay, what we'll do here is, let me just copy paste this console log. So compare. Okay, so what I'll do, buffer 6, we don't need this dot, you have to do equals. Okay, equals of buffer 7. So what we're trying to do here is we're trying to compare between the buffers. Okay, so this will give you true, both are same, and if you try with 8, right, it should give you false. Okay, let's run this. You can see it has given true for the first wherever it is matched and false wherever it is not matched. Okay, that is how you compare. Now let's see how do you encode the like buffer encoding, like from to a hex or base 64. Okay, so what I'll do is I'll take this as another 9th buffer. Then what I'll do is I'll try to convert this into a hex. Okay, so what I'll do, cons hex string equal to, so what we will do, buffer 9 dot to string of hex. This is how you convert this. Okay, so let's try to print this and also convert this into a base 64. Okay, so what we'll do here, same thing, it will be converted here and it will be giving the values. Okay, so let's try to print this hex string. Okay, so let's try to print as this. Okay, now let's try to print the base 64 version also. You can see it has converted accordingly to the hex string and the base 64. So this is how you play around with the encoding. Okay, so now let's see what are the best practices we have to follow when using buffers, right? First, use buffer.alloc instead of buffer, which always use this to avoid the security risk. Okay, manage buffer size, allocate only the necessary buffer size to avoid the memory waste. Buffers are fixed in size, so creating overly large buffers can lead to inefficient memory usage. Okay, handle data efficiently, like use buffers with streams for efficient handling of large files, avoiding the loading of entire files into memory. Okay, avoid blocking code, like when working with input output operations like reading from files or streams, use asynchronous method to prevent blocking and event loop. Clear buffers after use, that is very important. Use buffer encoding properly, like choose the correct encoding when converting buffers to string and make sure it is consistent across your application. Buffer concatenations, yes, when concatenating multiple buffers, use the concat method instead of manually joining, which is more efficient. Okay. Limit buffer size in incoming data. Like for security and performance, always limit the size of incoming buffer when working with the network and file. So it prevents the denial attack, like DOS attacks, right? Security attacks. Check buffer length. Always check buffer length before reading or writing to avoid going out of bounds and causing errors or unexpected behavior. Use streams where possible, like when dealing with large amount of data, prefer streams combined with buffers to avoid high memory usage. So following these best practices ensures efficient, secure, and efficient use of buffers in your Node.js application. So that wraps up our deep dive into the Node.js buffer. As we have seen, buffers are a powerful tool for handling raw binary data in Node.js, and they play a crucial role in working with streams, file systems, network connections. So whether you're managing large files, processing image data, or building real-time application, understanding buffers will help you optimize performance and handle data efficiently. So in next session, I would be explaining about Streams module and its different features and live examples. So if you have enjoyed this tutorial and found it helpful, be sure to give it a thumbs up, subscribe to the channel and ring the notification bell so you don't miss future updates. There's a lot more to explore in Node.js and I can't wait to dive into more exciting topics with you guys. Thanks for watching and see you in the next one.